Good afternoon, everyone. Thank you for joining us today for the application availability strategies for the private cloud. I hope you all have been having an awesome TechEd so far, and you all are totally revved up about Windows Server 2012 R2. And we hope it'll be more so after this session. My name is Subhashish Bhattacharya, and I'm a program manager for the failover clustering team. I'll be presenting this session with Jose Barreto. Out there, Jose. So I think you all will all agree with me that for your production environment, having your applications up is totally pivotal. So that provides the motivation for this session. Here's the plan for our session today. I'll start off with an orientation, kind of a context behind our talk today. Then I'll present our first application availability strategy, VM monitoring. This is a low-weight monitoring and recovery solution which we introduced in Windows Server 2012. Then I'll move on to the second strategy that we'll present. That's guest clustering. So I'll talk about what guest clustering is, some of the considerations that you should take into account when you're deploying guest clustering. But my main goal will be to set the groundwork for Jose's talk. If you ask me, what's the cluster feature that I'm most excited about in Windows Server 2012 R2, I'd tell you shared VHDX. And that's what Jose is going to be talking about. Last year, at our Ask the Experts table, I think we had a Microsoft private cloud table. And the most common question that was being asked is, hey, what is the Microsoft private cloud? So I guess my answer here is that the Microsoft private cloud is a set of Windows nodes which are part of a failover cluster. They're running the Hyper-V VM workload, and these are deployed and managed by System Center. So what exactly does this manifest for you and your production environment? So this means for deployment, you can leverage SCVMM templates. So if you are deploying several Windows nodes, you can use the same template, and it's seamless. You have VM mobility. So this is allowing you to optimize your VM resources. If you need to patch VMs, you can just move VMs across the nodes in your private cloud. You can move the VMs between private clouds, and you can move VMs outside the private cloud and back. Then for disaster recovery, you have an option to use our in-house data protection manager. Or you have an option to use, for asynchronous replication, you can use Hyper-V Replica. Or if you're looking for synchronous replication, we have worked with our third-party partners, such as Symantec and DoubleTake and SteelEye, to provide solutions for you. But the context of our discussion today is availability for your private cloud. So I guess one point I want to put across is that if you're in the private cloud, you have availability for free. So if you have what we call a host cluster, that's essentially your Windows workstations connected and part of a failover cluster. For free, you're getting availability or failover in case you have any OS health problems, you have VM health problems, or in Windows Server 2012, we also have media sync. So if your VM network goes down, we are going to fail over your VM to another node in the class. We are going to live migrate it. But one thing that you do not have in a host cluster is that application failures are transparent to the host cluster. So let's say you are running SQL in your host cluster, and SQL fails. The host cluster is just going to go on as if nothing's gone wrong. So clearly, we need to do better. And that's what we are going to talk about for the rest of this session. So the first strategy that I want to present to you is VM monitoring. So what exactly is this VM monitoring? What's the value prop for you? I mean, when you go into your production environment, why should you turn on VM monitoring? So the first value prop for you is that it allows you to monitor the health of the workloads in your VM. So let's say you have 1,000 VMs in your cluster. You can turn on VM monitoring pretty easily for all the VMs in this cluster. And then when you have a failure in any one of the VMs, you're going to be able to detect it in your host, which is hosting the VMs. And you can set the trigger either at the host level, or your guest administrator can set the trigger, which is going to get your VM into application critical state. But the second value prop, which is independent to the first value prop, I mean, so you can just have VM monitoring for detection. But we also provide you with a mechanism to have default recovery actions. So I'm going to talk more about that in a couple of slides. But if you aren't happy with our default recovery actions, you can set options so that you can customize your recovery actions. So that gives you a lot more flexibility to do what you, I mean, since you're customizing what you're monitoring, it would make sense to have the ability to customize what you're recovering from as well. So what can you monitor using VM monitoring? Any Windows service. So if you write your own Windows service, you can set VM monitoring for that. Or you can monitor standard Windows services, SQL, IIS, print server. But what is really powerful, at least according to me, is that you can set VM monitoring to trigger off any event which is logged to the Windows ETW logging. So just think of it, any event that your application is generating and you're concerned about, you can configure VM monitoring to trigger off that event. So as I mentioned to you, by default, we enable our default recovery mechanism when VM monitoring is triggered. But that brings up, so essentially our default recovery action is that for your first failure, we're going to do a graceful but forced restart of your VM. And for your second failure, we are going to fail over your VM to another node in the cluster. So when we first introduced this, we didn't have an option to customize your recovery actions. So, I mean, at the beginning, people were pretty happy with what they were seeing. But then they had questions. Hey, if we are going to patch our VMs, which have the workload, I mean, we clearly want to disable VM monitoring, or we don't want to get into app critical state when we are doing maintenance actions on this VM. So in this case, you can have your VM monitors still triggered, but you can disable the automatic recovery mechanism. In another case, like people told us that, hey, right now we are using Ops Manager. And how does this fit in? I mean, if we use your default recovery mechanism, I mean, you're going to reboot the VM for us, and Ops Manager is not going to figure out what's going on. So you'd probably want, in this case, to again turn off the default recovery action and let Ops Manager handle the event that VM monitoring produces. So just to reiterate our default recovery mechanism, so you have, in the beginning, your first recovery is at the guest level, and then for a second VM monitoring failure, the recovery is at the host level. As I mentioned, we generate event 1250 on the host cluster when we detect an app critical state. So this event's going to get logged whether or not you have default recovery enabled. So you can use this event to customize your own recovery tasks. For example, you can set a clustered scheduled task, which is triggered off this event, and that can do anything. For example, it can send you an email to warn you that, hey, this VM is in trouble. We don't want the default recovery mechanism because this might be a production VM, and we need specific permissions before we can even reboot the VM. So how do we configure VM monitoring? So let's start off. You have two options to configure VM monitoring. You can either configure it on the host, or you can configure it on the guest. And there are different motivations for configuring it in different places. So on the host, you can use failover cluster manager. Get on your VM, right-click, and that's going to expose more actions and then configure monitoring. And when you click that, it's going to present to you a filtered list of what we think are important Windows services. I mean, you can imagine if we didn't filter this list, you'd have probably 100 services, and you'd kind of be lost trying to find what service was important. But then you can configure it using PowerShell. And that gives you an option to configure monitoring for any service that you want to. But this is also the mechanism to configure monitoring for any event that you care about. So when that event is generated on the guest, your VM is going to go into app critical state. But then, I mean, you can get into circumstances where you have different administrators for your guest VMs and for your host VMs. So you probably want to delegate the trigger mechanism controls to the administrator of your guest. So then we also allow you to go ahead and, using PowerShell, to configure VM monitoring directly on the guest. So the first three commandlets are kind of self-explanatory. So I'm going to talk about the last commandlet. That's reset cluster VM monitored state. So this becomes relevant when you're using the customized recovery option. Because what we are going to do when you have a critical failure, we are going to leave the VM in an app critical state. And we'll let you or your script that you have written or your tools to handle the failure. Once you've handled the failure, you're going to call reset clustered VM monitored state. And that's going to reset the state of your VM. So that will indicate to the cluster service, hey, this VM is now in a good state again. So just to reiterate, VM monitoring is a lightweight mechanism. I mean, it's in box. It's easy to configure. But I guess, you get the advantages of the private cloud. Because, I mean, if you're moving your VMs around, this VM monitoring settings are migrated with your VM as well. But it's not perfect. Because VM monitoring is not, it's reactive. It does not poll your service to see if it's in trouble or not. So your service gets into trouble, and then VM monitoring acts. And a second disadvantage of VM monitoring here is that your application is tied to the VM. So if you want to patch your VM, I guess your application is tied in, and you get some downtime for your application. So this is a good solution to either supplement your primary recovery mechanism, or you can use it as a primary recovery mechanism for Tier 2 applications. But you really want to do better. So a better mechanism is guest clustering. What is guest clustering? Essentially, in your VMs, you have the failover clustering role installed, and you create a cluster for these VMs. This, as you can imagine, gives you proactive failure detection for your application. Your application now has mobility. In cases of failures, it can move independent of your VM. So now you're protected from application failures. if your SQL in your guest cluster fails, will fail over your SQL instance to the other VM, which is part of the guest cluster. So let's think about the differences between host clustering and guest clustering. So host clustering, you have your VMs moving from server to server. Guest clustering, you have your apps moving from VM to VM. But in host clustering, you have zero downtime because you're live migrating your VMs. But in guest clustering, you do have a small downtime. And also, for host clustering, you can just set up a gen app or a gen service. You're sort of, it works with any application or any guest OS. But guest clustering requires your application to be cluster aware. And as you can imagine, since you need at least 2 VMs to form a guest cluster, you're increasing the resources that you require. So you're doubling, you require 2 nodes for each application at the minimum that you want to protect. So most of this table is obvious, but what you have in addition to host clustering is that now you are able to detect application failures for either your cluster or your single node. So, I mean, you can have a guest cluster on a single Windows Server node, or you can have guest clustering on top of a host cluster. Obviously, the latter is preferable because if your node goes down, you want to be able to fail over your guest cluster to another node in the cluster. What are your storage options for the guest cluster? Actually, this table makes me, I was working on this table a couple of weeks back, and it kind of made me warm and fuzzy. Because in TechEd 2010, we had the same table, but we just had one check on the right column. All we supported for guest clusters was iSCSI. But now, it makes me good to say that we have other options for you. In Windows Server 2012, we added support for Fiber Channel. And now, in Windows Server 2012 R2, we have support for SAS and a scale-out file server for shared VHDX. Essentially, the huge value prop for shared VHDX is now you are dissociating your infrastructure from your tenant. So if you have a hoster environment, for example, your hoster no longer needs to be aware of the infrastructure that's being presented to it. And Jose is going to go in depth into this. So let's talk about a few deployment considerations. So first deployment consideration I'd like to talk about is your heartbeat settings. In particular, the same subnet threshold. So essentially what this is you know that your cluster nodes are sending heartbeat packets between each other. And if we miss a certain number of heartbeat packets from a certain node, we are going to remove the node from cluster membership. And by default, this is set to 5. But for your guest cluster, you can run into, for live migration, you can run into a blackout period. And a same subnet threshold of 5 might just not be enough. So you might want to bump it up to 10, or whatever works for your infrastructure. But in Windows Server 2012 R2, for VMs by default, we've set it to the relaxed setting. So your same subnet threshold by default in Windows Server 2012 R2 is 10. And you probably, we'd recommend that you consider tweaking this setting for your guest clusters in perhaps 2008 R2 and 2012 as well. A second consideration, which kind of makes sense, is if you have a host cluster which you have your guest cluster on, it kind of makes sense to keep your 2 VMs forming the guest cluster off each other. And the way you do this is using the VM resource property anti-affinity class names. So if 2 VMs have the same anti-affinity class name tag, we are going to try our best to keep these VMs off the same node. So I've included the PowerShell command that will help you get this done. A common question that we get is, hey, can we mix physical and virtual nodes in our cluster? Can we create a cluster which has, say, one physical node and one virtual node? The answer is yes, you can. But you need to make sure that cluster validation passes, and so that you ensure that your storage configuration is in place. So what sort of a scenario would this be helpful in? So you might be running your workload primarily on the physical node. But for a backup, you want it to fail over to a VM node. A second and common question we get is, hey, will guest clustering work with ESX guests? From our end, we don't have any restrictions. But I defer you to a knowledge base article that they've written. So I put the link in here. But I have to warn you, this article is kind of like, to me, it's like an Alfred Hitchcock novel. I mean, you look into it, and then you have to look at the limitations, and the limitations are hidden somewhere. And for example, for their support statement for Windows Server 2012, in the first link I said, they said they do support it. The second support statement here, they say they do not support it. So I'm not sure what their exact statement is. They have not done the work to go get SVVP certified. So I guess my take in this would be, if you have an option, it would be best, I mean, the most efficient for you would be to go from top to bottom using the Microsoft stack. So Hyper-V, Windows Server OS, that would give you your optimal performance. But if you need to use ESX, guest clustering on ESX guests, that's supported. So a quick summary. So for a host cluster, which you get for free in your private cloud, you have OS health for your both your host and your VM. It provides you VM mobility. VM monitoring is a lightweight solution. You can detect application health, but you don't really have application mobility for your VMs. And guest clustering is sort of the most complete option for you, but it does take a little bit of configuration, which has become much simpler now with shared VHDX. And you have a little bit of overhead for infrastructure. So before I know all of you all are waiting to hear about shared VHDX, but I'm going to take up a little bit more time for a demo. So what I'm going to show you is, let's see, let me get my demo back up. So what I have here is I have a host cluster here which has 2 VMs. And I have created a guest cluster using those VMs. And I'm using iSCSI storage here. But obviously, once you all are done with this session, you all would all use shared VHDX. And I've presented that storage to cluster shared volumes. And I have a continuously available scale-out file server on that CSV volume. And I'm going to be playing a video of that share. And the thing to note here is that the owner node for the scale-out file server is VM1. What I'm going to do here is I'm going to go on and turn VM monitoring for this VM. I'm going to turn on monitoring for the cluster service. And what I'm going to do after that is I'm going to go ahead and kill the cluster service. So what I'd expect happening here is that the video is going to keep running. The guest cluster is going to detect that one of the nodes in the cluster is temporarily not available. It's going to fail over the application to VM2. And VM monitoring is going to detect that the VM1, which it was monitoring, has gone down, and it's going to attempt a recovery. So I go to Process Explorer. I go ahead, kill the cluster service process. Oops. And you see that it's detected that your application is in VM app critical state. But then it detects that, and it restarts your VM of a forced but graceful restart of your VM, and your VM is now up. And if you go back to your guest cluster, you notice that your scale-out file server role has now moved from VM1 to VM2. Now, if I go back and kill the cluster service again for VM1, what we are going to see is this time, VM monitoring is going to fail over your VM node. But before that, while the VM is still coming up, let me show you a couple of settings. So let's go have a look at the cluster event log. So you see event 1250. That's the event that's logged when your VM is in app critical state. So if we didn't have the default recovery mechanism, you could figure something else of your own. If you didn't want to handle every failure, maybe you could handle every 10th failure. Or if you don't want a forced restart of your VM, maybe you could configure it to do a live migration of your VM. So let's go back here. And a couple more things I want to show you. So let's go to the resources for this VM. And if you go to properties, so in advanced properties, here's the interval for how often it's going to check for your VM app critical health state. By default, this is 1 minute. I set it to 5 seconds because, I don't want you all waiting for a minute in this demo. But for you, you need to think about the trade-off. We haven't really seen much of a perf impact for setting this to 5 seconds. But, in case it does, you might want to find the sweet spot for yourself. The second setting that I want to show you is here, enable automatic recovery for application health monitoring. So if I were to uncheck this, it's not going to do the default recovery mechanism, and it's going to wait for you to handle the failure. So let's log back here and try killing cluster service again. So again, you see, we've detected that we've gotten into app critical state again. And this time, we are going to try to fail over this VM. So that's VM1. We are going to try moving it from node 1 to node 2. So that's pretty much my demo. And now I'm going to hand over to Jose to talk about shared VHDX.
Oops. Thank you, Subhashish. And I hope you understand that what we're trying to do here is actually to give you the best possible tools to create highly available virtual machines, right? And one of the things that we have heard over and over again is, first of all, applications used to be deployed bare metal. You know that. We used to have SQL servers running bare metal in cluster configurations and all that. And you had all these file servers deployed in bare metal configurations. And more, what we see is that everything is getting virtualized. With the changes we have in 2012, even your largest database deployments will now fit in a virtual machine. And the notion is everything will be virtualized. If you look at our infrastructure as a service vision, there are really only two things that are bare metal in that deployment. One is the Hyper-V nodes themselves. So the Hyper-V boxes obviously are bare metal. And the other one is the storage layer that you use for Hyper-V and nothing else. And in many situations, you will need, for instance, a database service that you need to offer to your infrastructure, and those will be running virtualized. In many cases, you will have, for instance, a file server solution that is not file server for Hyper-V storage. It's a traditional file server. And in many cases, you will go ahead and deploy those as virtual machines. Even more so when you are operating as a hoster, right? If you are in an enterprise environment, you might say, oh, Jose, I think it's okay to deploy my file services on the same machine that I deployed for my Hyper-V storage. So that's a fine thing to do if you are all in the same domain and if you are all using the same security infrastructure across your deployment. But more and more, people are operating under the premises that you are going to have a private cloud that provides VM service, so it's infrastructure as a service, and everything gets deployed inside VMs. That includes, for instance, database services and traditional file services that you might want to have. And as Subhashish has shown you, we can provide higher availability for that private cloud through the use of host clustering, and we can also do it through the use of guest clustering. And we can even combine the two methods. So you can have both host and guest clustering. Yes, it does make sense to make them both be there at the same time. Now, the problem that we had is, as much as we try to make this as simple as possible, we did have something in 2012 that was dependent on specific technology for the storage that you needed. So you had to use iSCSI to the guest or virtual fiber channel. And those, although they were creating a requirement for you to expose your storage all the way to the guest. And then there's the fact that we're now talking a lot about cluster storage spaces, and we're talking a lot about scale-out file server storage solutions, and those did not have a straightforward way to be taken to the guest. And that takes us to our new feature, which is the ability to simply have shared storage for your guest clusters using shared VHDX files. So I want to make clear, what you need here is one VHD for each VM so that you can boot. So the OS VHD, by all means, is not shared, but you will have, in addition to that OS VHD, you have additional data VHDX files that are going to be shared, okay? So the notion is you simply share this, for instance, if it's a CSV environment that you have, you put a VHDX on your CSV and you expose that data VHDX to both, okay? Or if you're using file storage, same thing. You expose that same VHDX file to multiple VMs. And from your guest perspective, you just get a disk. So you have a disk that shows up and it looks like shared SAS. So when you go inside, you see a disk that you boot from, and then you see this data disk. And when you go ahead and you run the cluster validation say, hey, I see that you have disks that are compatible with failover clustering. I'll go ahead and let you use those to create your guest cluster. And that's as simple as that. So Jose, I don't need iSCSI in the guest. No, you don't. I don't need virtual fiber channel. No, you don't. How does this happen? Well, we worked with the Hyper-V team, and they now have this new offer in the guest that the disks that are exposed through the SCSI controllers are actually full-blown SAS disks. What does it mean to say that it's SAS disk? It means that they have the ability to do persistent reservations. They are shareable SCSI disk devices, okay? And it's kind of ironic that they actually mimic the same kind of infrastructure that we're now using at the host level. But that's fine. The guest itself doesn't know what's going on, which is par for the course when you're talking about virtualization, right? So the guest sees a disk, and I also get the question, Jose, how do I figure out from inside the guest if the shared VHDX that I have on the other side is iSCSI, fiber channel, file share, cluster spaces? The answer is you don't. From the guest's perspective, you really cannot tell what's going on. You see a disk that looks like a SAS disk, and you use it, but on the outside, on the host side, you really can use any kind of storage that is compatible with your Hyper-V deployment. Now, we put a little bit of a limitation there entirely because our ability to do testing is limited. So we have two basic scenarios that we're going to say there are supported scenarios for shared VHDX. The first one is you put your shared VHDX file on a CSV volume. So in that case, obviously, you have two nodes, two virtual machines. As I explained, you have your boot disk here that you're using on each side. So VM1 boots from VHDX1, VM2 boots from VHDX2, and then you have this VHDX3, which, if you notice, is exposed to both sides. In this case, I'm using storage spaces directly exposed to the two nodes. So small configurations, as I can probably explain very easily, you don't have that separation between your storage layer and your compute layer because you only have two hosts, right? So you use cluster storage spaces directly with the Hyper-V host. That works fine. This is also a fair way to do it if you, at the bottom here, instead of storage spaces, you had a fiber channel SAN, or if you have an iSCSI SAN. Those things get exposed to the hosts. You create a CSV on the host, and then you have a VHDX file that all nodes can see. All you need to do is share it, okay? So this configuration effectively replaces the need to do iSCSI to the guest or virtual fiber channel. And the fun thing about this is, have you tried to deploy iSCSI to the guest? So what is the thing that you need to do? Wire the network to the guest that lets each of your guests see your iSCSI target. Have you tried to deploy iSCSI to the guest at the same time that you're deploying network virtualization? It's loads of fun. Okay? So you have to actually give that. Let's say, for instance, you're a hoster, and you have a lot of VMs. They're all using this single iSCSI target. You actually have to let all your guests talk to that single target. It is not very good for this multi-tenancy environment. In this environment here, what does the VM see? Only the VHDs that were properly exposed to that VM, right? And nothing else. How does the VM talk to the storage? Through the storage layer in the guest, okay? So it's very much ready for multi-tenancy. It's much safer to deploy. Now, obviously, you know that I am also doing a lot of work with SMB 3.0, and that is the other scenario that we have. So same idea, you have multiple Hyper-V nodes, multiple VMs, and your VHD files are sitting on a scale-out file share. Jose, can I use a standalone file server? Technically, no, because we don't support it. We assume that if you're going through all this trouble, you want to make sure that the entire solution is highly available. So deploying this against a standalone file server would make very little sense, right? Jose, can I use a traditional file server cluster instead of scale-out cluster? Well, we don't support that either. Why? Because if you have the hardware to create a a traditional file server, you can also do it with a scale-out file server. It's the same requirements. So there's no good reason to go with the traditional one if you're doing Hyper-V over SMB. So we are essentially not testing that and say, use the scale-out file server. Okay? So how do you do it? Well, you either, in Hyper-V Manager, check a box when you're creating the VM, or in PowerShell, you use the dash shared VHDX option, or in VMM, you use a service template. We're going to show a little demo of this. And inside the VM, there's really nothing that you need to do. I do highlight two things that Subhashish has shown. First, the anti-affinity capabilities that you have on the host side, and the heart beating. So he covered that in the slide. So make sure that you take that into consideration. So speaking of that checkbox, right? So it is when you create a disk under a SCSI controller, under advanced features, you will see that we now have this little checkbox called Enable Virtual Hard Disk Sharing. If you're doing this on the command line, all you have to do is create a VHD as you would normally. So there's nothing special about the VHD that you're sharing. The only thing that you have to make sure that it's a VHDX, right? We do not support that for the old VHD, okay? Has to be VHDX. And then when you're adding to the different VMs, you use this shared virtual disk option. That's it. That's the entire set of things that you have to do differently. It's one option on adding the virtual disk. And if you want to query the VMs to see what's going on, look for this support persistent reservations property. I know it should be called shared virtual disk, shouldn't it? But as technical people, we know that the difference between a shared disk and a non-shared disk is the fact that they actually support persistent reservation. So that's the name of the property. In VMM, in the service template, that's kind of blurry. There is a place where you can set this share the disk across the service tier. Okay? And inside the VM, you really can't tell. You can go poke everywhere inside the VM. There's no way that you can tell that this is not just a disk, right? And that's how it should be, right? The VM shouldn't have to know. The VM shouldn't know. Let's do a little demo. All right. So first up here, let me show you this cluster. It's a kind of an interesting thing to demo this because I always mention the movie Inception. Have you seen the movie Inception? It's a fun, interesting movie. There's a dream within a dream within a dream, right? So in this environment, I have a file server cluster which provides me with storage. Then I have a Hyper-V cluster. That's where I put my VMs. And then inside the VMs, I create yet another cluster. So there are 3 clusters involved here. You have enough of this? Okay. But you see, we're actually simplifying this because they now look a lot more like each other. And there's less requirements across the way. Okay, let's start. Let's assume that we have my nodes A1, A2, A3, which are my file server clusters. They are working, trust me. And I'm going to focus here on my B1, B2 cluster, okay? going over here, you can see that I have 2 nodes. And as I told you, we have a VM in one node, and I have another VM in the other node. Okay? Then I'm going to minimize this and look inside the VM. So this is my X1, X2 cluster. So inside this third cluster, I have one node called X1, the other node called X2. And inside there, I have a SQL Server cluster. So if you look in there, this looks like any cluster that you have seen before. I have SQL running. SQL has a proper name resource, an IP resource. It has a disk, and it's running, and it's happy. Now, if you go look here at the disks, you will see that I have a witness, and I have my data disk. And I can safely go in here and say, hey, I need to do maintenance on this node, so I'm going to move that to the other node. And what you see is in traditional failover cluster fashion, we're going to stop those resources, move them over to the other node, bring them back online on the other node, and soon enough, this resource went from X1 to X2. Right there, you see the reason why we go through all this trouble to create a guest cluster. Did you see how fast that was? You know why we can make this transition between the 2 nodes so quickly? Because SQL is already running on both nodes, right? You already have SQL Server loaded, available, installed on both nodes. All you need to do, essentially, is to move from one node to the next, is take down the disk resource, mount them on the other side, bring them back up. That can happen very quickly, especially if you do a clean shutdown on the other side. Okay? If you're trying to do this in a predictable fashion, it makes sense, but it makes even more sense when you are doing this on a surprise failover, which is the real story that people don't tell about host clusters. And if you ever work with host clusters, say, oh, we can move this VM that's running from point A to point B through live migration, right? So if you cluster the VM at the host level, you can move it between nodes with no downtime. That's awesome. Now, what happens if you actually have a failure on that node? So you have a machine that has a VM, highly available VM. The machine has a power failure. What happens? You are going to bring that resource on the other host. However, if you're doing this as a host cluster, the VM resource, the memory that you had running, disappears. So the way that VM comes up on the other node is it brings the entire boot process on the other side. You have to do a full boot of the machine. Let's say it's a SQL machine. You have to actually load the OS, load SQL, and then go over the recovery process and bring it back online. That is going to take some time. It's not going to be 2 or 3 seconds. It's going to take a little longer, okay? And if you're doing this with a guest cluster, what's going to happen? You lose that VM. The other VM on the other node is already up and running. We're doing heartbeats at a certain time. Depending on how you configure it, we could detect that in just a few seconds. And then we bring up the thing quickly on the other end. That's the difference between host cluster and guest cluster. Now, if you're combining both, what's going to happen is the node that dies will eventually recover on another place. And when it does recover, it reestablishes the guest cluster. So the other VM that you actually bring up somewhere else, it will eventually come back up, SQL will load, and they're going to say, oh, hey, I'm back, right? And it's going to say, okay, can I join that cluster again? You say, okay, but you're no longer running the service. Just stay there. And now it becomes the other VM that's not running the service. Okay? Now, if you're running a scale-out file server inside the guest, or a traditional file server inside the guest, we can actually do it transparently. Now, go think about that a little bit. Okay. Now, let me show you a little bit of this from the host perspective. Because from the guest, it's not really exciting. It's the same failover cluster service that you know and love, right? Let's take a look at here from a Hyper-V manager perspective. So I'm going to go ahead and go to B1. I'm going to take a look at this VM and say, okay, let's look at the settings. What is different about this VM setting? So you see that I have my IDE drive here, regular drive, that's where you boot from. This is not shared, and it doesn't have to be SCSI. So if you look here under the advanced feature, this is not enabled for sharing, and it shouldn't be. Okay? Now, what I do have here is the set of disks that I am sharing under the SCSI controller. So I have my advanced features, see here, enable virtual hard disk sharing. Same thing here. My data disk, go to the advanced features, enable virtual hard disk sharing. So that is it. That's the only difference between VMs that are using shared VHDX and VMs that are not using shared VHDX. So no zoning, no unmasking, no worldwide names, no IQNs, none of that. All you have to do is have one shared file and one checkbox. Okay? Now, you know I like my PowerShell. So let's look at this from a PowerShell perspective. So I look at my VM1. My VM1 is running, right? And you see that I have my boot disk. It's here, see? VM1 OS. And I have my two shared disks. Now, when you first look at this, essentially I'm doing a get VM and I'm piping to get VM hard disk drive, right? You will see that these look the same. There's only that property that we talked about, support persistent reservation, which is true for the last two of my disks. So reinforcing OS disk, not shared, data disks, shared. So this is for one of the VMs. You obviously have to do this for the other VM as well. So this is my VM2, which has another file to boot from, but shares the exact same data disks. And if you look at this from the perspective of the scale-out file server, that's kind of a fun little thing. How can you tell that these are being shared or not shared? So I'm looking at all the files that are currently open. So I'm using a get SMB open file. So you see that I have my configuration file, my bin, my save. And when I look at my data, look at this little detail here. So you will know that when you're sharing the VHD, you will get that stream name over there, shared virtual disk, at the end of the file. That's how you can tell that those are being shared. Okay? Now, one last thing that I want to show here is, if you learn anything from the talks that we have been doing throughout this conference, is that we are working closely together, Windows Server and Virtual Machine Manager. And this wouldn't really be a complete solution if we didn't have a way to actually work together with VMM. How many of you have heard of service templates in VMM? Awesome. This is how you can represent this new capability. Now VMM has the notion of a set of VMs that work together. And this is the actual definition of a guest cluster, right? You have a set of VMs. They're related to each other because they actually share some data disks. And you could, in theory, if you know about service tiers in VMM, you know that you can actually have web servers that you can create multiple of, and then you can configure a load balancer to go and hit them all. And you can shrink the number of nodes or expand the number of nodes. We're now delivering the same notion for clustered services. So where would I find this? So I would go to my library, and I have here an example. I have a SQL service template. I'm going to go ahead here and open the designer. And here's what it looks like. This is a single-tier SQL. This is not a proper way to do it. What I should have done is I should have had a two-tier solution where I have some web servers and some SQL servers, and the web servers use the SQL server, and the web tier can scale independent of the SQL tier. I'm just keeping it simple here by creating just one SQL tier, okay? And what you see here is I have my tier, and it's being defined here, if you look at it, as having at least 2 instances, but I can go up to 4, meaning that I can have a 2-node cluster, and I can make it bigger. It's just a notion. For SQL, it actually doesn't make too much sense. For scale-out file server, it would actually make more sense. I can actually go ahead and adjust this. But the most important thing is coming over here and looking at the properties of this tier, and you go into hardware configuration. And what you will see here is that in the hardware configuration for this tier, I have an IDE device which says contains the operating system for this virtual machine. And then I have, under my SCSI adapter, I have a disk. And that disk has this little checkbox, which is all you need to do, which is shared the disk across the service tiers. What this means is that when VMM is deploying this tier, it is going to create a unique virtual disk for the OS. But when it's time to create the disk that you're sharing, it's going to deploy just one VHD for the entire tier, and that VHD is going to be shared. So now VMM has the proper understanding of how you go ahead and deploy this kind of solution. So let's say, for instance, I want to add another disk, right? And I'm going to go ahead and say, I'm going to on purpose do this. So this guy, I cannot share. Can you guess why? It must be a VHDX, right? Okay, no problem. I can fix that. I'm going to make it a VHDX. Still can't share it. Why? Exactly. It's not SCSI. So let's put it on the SCSI bus. Now I can share it. So not only VMM supports this, but VMM has the knowledge that there are restrictions on the disks you can and you cannot share. And when you're doing this, you just have to be careful that you always use SCSI and you always use VHDX format. VMM will help you along the way. Okay? All right. Let me go back here to my content. So that is the gist of it. Yes, a question. So the question is whether shared VHDX will be supported on Generation 2 virtual machines. Absolutely. Now be careful there, because Gen 2 virtual machines can actually boot from SCSI. So don't share those. They are SCSI, but if they're boot disks, they should not be shared. Just the data disks are shared, okay? Speaking of Generation 2, this scenario required us to work with the Hyper-V team, and there are changes in Hyper-V, and there are changes in failover clustering. So in order to make this work, you have to be running Windows Server 2012 R2 on your compute layer and on your storage layer, okay? The other question that I get a lot is, Jose, can I do this against a third-party SMB 3.0 implementation? The answer is yes, if they implement the proper protocol. We have just published the new protocol documentation for remote shared virtual hard disks. And there are specific things that need to be done there. And so far, of course, protocol documentation was recently released, but we do expect some folks to go ahead and implement the protocol as well. Okay? So it's doable. Yes? I couldn't hear. Oh, if you want to change the size of the VHDX files, well, we cannot do online resize. But if you stop, you can offline resize, and it will just pick it up when it comes back. Okay? Yes. I have a slide on that. I'll get you back up. Okay. The other thing is in the guest. And again, it's a function of our ability to test the scenario. So all you need to do in the guests is make sure you load the integration components. Okay? And that is true for any VM you do. Don't do it just because of shared VHDX. Do it as a best practice. Always load the integration components. But if you do not load the integration components, you don't see the new shared SaaS infrastructure. Okay? So just be careful with that. A lot of folks come to us, oh, it's failing cluster validation. Did you install the components? Oh, I forgot. Then yes, it will fail because it won't look like shared SaaS. It will look like old SCSI. Right? Be sure to do that. We do support Windows Server 2012 or 2012 R2. And before you ask, this will also work for 2008 and 2008 R2 guests. The only thing is we have a thorough battery of tests that we run, and we just didn't have the resources to go test all the way back. So 2012 and 2012 R2 in the guest are supported. Older versions of the OS, in theory, should just work. We're not flagging that as supported simply because of our ability to test the scenario. And you know what support means, right? Support means that we tried this, and we stressed it, and we did everything that we could to make sure that you don't hit any issues, right? So that is why we're saying supported for 2012 and 2012 R2 only. If you feel like we should go further back, let me know. Okay? Oops. Wrong keyboard. Virtual disk format, that is important. You must use VHDX, not VHD. Jose, why are you doing this? Is it just because you don't like the old format? No, there's actually a technical reason for it. VHDX files have a metadata header capability. So you can put metadata in the header of the VHDX file. And the reservations that we use were actually leveraging that. So we couldn't do it in the VHD, or I guess we would have to be doing something different if we were to support the old ones. And honestly, you shouldn't be using that old thing anyway. It's a new scenario. Use VHDX. It's much better, believe me. The other thing, if I didn't say this enough, this is not for the OS, just for data disks. And last but not least, we support fixed or dynamic, but we don't support differencing. We thought really hard about this, and we see no reason for you to use a differencing disk for data. If you think that's an important scenario, let me know. So far, most people just nod when I say, yeah, we don't support differencing. Differencing disks, the scenarios that I've seen, most cases are you have an OS, and you create a diff from the OS so that you implement the OS without having to copy over the same bits over and over again. Okay? Backup. Backup is something we need to address. Okay. First thing is, for our backup solution, we are requiring you to do the backup from the guest. Jose, I wanted to do host backup. Me too. Okay? We just had 1 year to get this one done. So I'll be very upfront with you. We just didn't have enough time to do it. It is not trivial, though, because we have multiple VMs accessing the same VHD. And you know what happens when you do a snapshot of a VHD file? You actually take the file, create a new one, you point to the new one, and that one becomes a diff of the old one, right? Now, if you have a whole lot of machines all using that, you have to synchronize that change across the different ones. So we decided that for R2, we don't support snapshots. Yes? Well, technically, what happens if you try to do anything that we don't support, it should not be enabled. So from a GUI perspective, you should not be able to do it. From a command line, if you try to do it, it should fail. Now, there are scenarios where, for instance, you can snapshot the OS disk. You can't snapshot the data portion. Well, if you're doing snapshots at the array level, so the question is, can I do a snapshot at the array level even though I'm not supporting the synchronized VSS backup? That's a crash consistent snapshot. I guess if you're okay with that, that's fine. But we don't actually do the proper work to go inside the guest. So the whole notion of host backups is that you go inside and you make sure that the applications are consistent state, and then you bring it out and you do all the dance, the VSS dance, right? So if you want to do that, you have to do it from inside the guest, and from inside the guest, we'll use VolSnap. We use the built-in software snapshot provider, and that should just work. But you can't do that from the outside. And by all means, this is not a regression on guest clustering scenarios, because for virtual fiber channel and for iSCSI to the guest, we also do not support host-based backup. That's why we thought it was okay to have a first release out where you are required to keep doing your backups from the guest. Okay? And I do understand, I've been hearing a lot, backup is an important scenario. So you have to do it from the guest. Okay? The other thing is, what can you fail? So this feature is all about high availability. So you want to make sure that you can tolerate all different kinds of failures. So your guest can fail. So if for some reason your VM goes away, that's fine. You can turn off your VM unannounced, and you give the failover behavior to the other node of your guest cluster, right? You can also have an entire host fail as long as you're taking care of your anti-affinity, right? If you have the two VMs in the guest cluster in the same host, and you turn off that host, guess what? You turn off your entire guest cluster. That won't work. But if you keep your VMs in separate hosts, you can lose any individual host, and we will probably fail over to the surviving VM. You can also fail the file server side if you're doing using the scale-out file server. So you can lose a node of the file server cluster, we'll do the transparent failover, and we also test this scenario for guest clusters using shared VHDX. Things that you can also do, you can move the coordination of the CSV volume across the node. So if you're using either scale-out or the cluster shared volume option, and you can live migrate the virtual machines. So you can move the virtual machines between nodes. Heads up though, when you're migrating VMs between nodes, there is a little bit of blackout time, and you have to make sure that the blackout time for the migration is not larger than the time that you're heartbeating the guest. If it is, then during migration you might see a failover occur in the guest. And you most likely don't want that to happen. Okay? We are testing this, and we will provide a little bit of guidance to say what should be your ideal configuration. But right now, as Subhashish has shown, there's a more relaxed setting that you can put for guest cluster, and that is to keep that in mind. But if you have lots of shared VHD files, the live migration between nodes is also going to take a little longer. Okay? So keep that in mind in your testing. Yes? Yes, so let me clarify. So the question is about the last bullet, storage migration not supported. So again, in order to do storage migration, we would have to coordinate multiple VMs at the same time. So we do not support this in the R2 release. And the way that you can move is you have to take downtime for that cluster. You have to take it down, you have to move it. You can optionally actually just take that disk offline, so you can remove, since these are SCSI disks, right, you can live remove the disk. You can move just the disk and reattach the disk, but that obviously means that you're not using that disk. So technically you don't have to take the VMs offline, you have to take the disks offline, make the move, and then reattach. But yes, if you have data on that disk that you're running, you're obviously going to have to incur some downtime there. Now, I would stress that these are things that we are fully aware of, okay? And I would love to hear your feedback saying, this should be next, okay? A little bit of a summary of what we're talking about here. So a little table talking about what we can do with virtual fiber channel, what we can do with iSCSI to the guest, which are our main scenarios up to 2012, and what shared VHDX will bring you. The main thing we're talking about here is shared VHDX make the whole scenario more consistent across the different types of storage solutions. And we believe that as we evolve this solution, it is going to be our preferred method for guest clustering, just because of how simple it is, okay? It is in the preview. I would highly recommend that you start experimenting with it in both the CSV scenario and the scale-out file server scenario. And one thing that I would stress is because we are using the storage path, we can actually leverage all the capabilities of SMB in the host. So you're not taking that networking to the guest. The networking goes to the host, and from the host to the guest, it's all through the VM bus in the storage VSP VSC. So you can actually do this with RDMA. You can actually do this with multi-channel, which is kind of nice. The other thing that I would highlight is our ability to just simply live migrate VMs with very little concern for how things need to be plumbed. Because essentially, you just need to make sure that if you're in a cluster, you're live migrating, that the storage is properly available on the source and on the destination. There's no plumbing of this to the guest. So all the complications related to virtual fiber channel like switch reconfiguration, multiple worldwide names, and all that goes away. So if you are today using virtual fiber channel, you might want to reconsider going through the shared VHDX simply to have less to configure in the case of migration. Does that make sense? Same kind of functionality, less work to do, okay? Few things, troubleshooting. We have added specific performance counters so you can monitor this. Now keep in mind that these performance counters are in the place where the VHDX are shared. So this you should do wherever the CSV volume lives. So if it's in the cluster, you look for the place where the CSV lives and look for the performance counters there, okay? And if you are in a scale-out file server, you will look at this on the scale-out file server side, not on the Hyper-V side. Might not be initially very obvious, but we are actually following the place where CSV is doing the work, okay? You have a lot of information about, time to mount, I/O, like IOPS and throughput and all that. And we have events that you can look, some details. And we operate as a filter, if you're into that. So filter manager is there. And this is the location of the components that we use. Last, I know I'm out of time, but last thing I want to do is, if you just want to try this out, we have actually a way to do this on a single machine if you manually attach the disks. The big yellow triangle means that this is not for production deployment. This is for test, dev, training. You could do it, right? I'm not going to spend much time on this, but I put it on the slide. If you're daring, you can go and play on this on a single machine. Not for production, please. Okay? So that's it. That was the talk. I wanted to highlight a few things. One of them is that the preliminary TechEd documentation is already out for this feature. So we now have a step-by-step on shared VHDX on TechNet. If you want to find the link, you can just go to the smb3.info URL. That's my blog. The top blog post there is a summary of all things R2, and in there there's a step-by-step for shared VHDX. Please exercise it. Play with it. Let us know what you think. We have some limited opportunity to go and gather your feedback, and please let us know what you think and how you're playing with it. Okay? Thank you for coming over here. I know it's a busy conference and there's lots going on in this time slot, but I enjoy your presence here. And if you have any additional questions, since we're out of time, I'm going to ask you to come over here and ask them in person. All right? Thank you.